Let's look at using AI to assess source information. Most of the inefficiency in technical writing isn't in the writing. It happens in the interactions with other teams at the start and end of the process, especially at the start. A software feature can be ready for release and still be almost impossible to document properly. For example, the technical writer might receive a completed development ticket, a few screenshots, and a message saying it works just like the previous version. But that doesn't tell the writer what they need to know. They need to know things like, who is the feature for? What problem does it solve? What permissions does someone need? What happens when something goes wrong? And has anyone confirmed that the final product actually behaves as described? The writer can investigate those questions. Technical writers do that all the time. But it takes time. It makes schedules difficult to predict, and it creates friction before the writing has even started. So, could AI help us identify those gaps earlier and help us to fix them? At Cherryleaf, we've been exploring an approach that uses AI to produce a documentation readiness score. The aim is to assess whether the source information is good enough before the documentation work begins. In this video, I'll explain what documentation readiness means, how a scoring system might work, where AI can help, and one important warning about using the score as a performance measure. So what does documentation readiness mean? Documentation readiness is a measure of whether a technical writer has enough reliable source information to begin and ultimately complete the documentation. It's not a measure of whether the software is ready to deploy. It doesn't assess the code quality, test coverage, or operational readiness. Instead, it assesses the information available to the writer. Depending on how your organization develops software, that information might be spread across development tickets, acceptance criteria, product specifications, architectural decision records, pull requests, API specifications, test cases, meeting transcripts, screenshots, working builds, and existing documentation. What you can do is have an AI agent or app examine that material and compare the available evidence with an agreed set of criteria. And the result is typically a score, together with an explanation of what is missing, where the sources disagree, and what the team needs to add before the technical writing team can proceed. The explanation is important, because a number on its own isn't much use. What problem is it trying to solve? Technical writers often discover information gaps only after the work has been scheduled. And let me give you some examples. A ticket might say that a feature is complete, but not identify the intended user. A specification might describe the expected workflow, while the working product behaves differently. The happy path might be clear, but the error messages, permissions and limitations are missing, and so on. The writer in those situations has a few choices, and none of them are really pleasant. They can begin drafting and mark large parts of the document for review. They can spend time interviewing developers and product managers. They can make assumptions, which might later appear in the published documentation. Or they can stop the work and explain why it cannot proceed. Stopping is sometimes the right decision, but if the problem is discovered late, it usually creates a rush, a crunch at the end of the project. What a documentation readiness score does is it moves that conversation earlier. It gives the writer a quick way to sort incoming work. It also gives the development team specific feedback. For example, the source pack scored 62 out of 100. The main workflow is documented, but the permission model and failure behavior are missing. Add the relevant test cases and confirm the required user role to reach the writing threshold. Now that is much more useful to everyone than just saying we need more source information. What a documentation readiness score does is it moves that conversation earlier. It gives the writer a quick way to sort incoming work. It also gives the development team specific feedback. For example, the source pack scored 62 out of 100. The main workflow is documented, but the permission model and failure behavior are missing. Add the relevant test cases and confirm the required user role to reach the writing threshold. Now that is much more useful to everyone than just saying we need more source information. So let's look at possible scoring models. A scoring system needs a defined rubric. In other words, everyone needs to agree what the score is measuring and what counts as evidence. One model could score each category from 0 to 4. 0 means no relevant information was found. 1 means the source information contained a claim, but there wasn't any supporting evidence. 2 means some information exists, but important gaps remain. 3 means the information is sufficient and supported by evidence. And 4 means someone has checked the information against the product as it was actually implemented. You can apply those levels to categories such as the intended user, the main workflow, permissions, error behavior, limitations, and verification. A weighted calculation would then produce an overall score out of 100. The thresholds will vary between organisations, but as a starting point, a score from 85 to 100 might mean the feature is ready to document and review. From 70 to 84, well, writing can begin, but named specific gaps must be resolved before publication. And from 50 to 69, that the writer needs to do more discovery before drafting. And as for under 50, the work goes back for more source information. These bands shouldn't be treated as a universal standard. You need to test them against real projects and adjust them to suit the risk and complexity of your own work. A high score doesn't always mean ready, and there is a problem with averages. They can hide important details. A source pack might contain detailed user interface labels, examples and test results, but it could still say nothing about the permissions needed to perform the task. This means some gaps should override the numerical score. For example, the target user or use case might be unknown. Two sources might disagree about the product's behavior. Security or compliance information might not have been approved. The writer might not be able to check the final user interface, API or command line behavior. Or a product decision that affects the documentation might still be open. Imagine a source pack scores 88 out of 100, but the permission rules haven't been approved. The dashboard should show both results. The readiness score, for example 88, and the status, for example blocked. And with that, the reason. Permission rules have not been approved. The score tells you how much useful information is present. The blocker tells you whether it is safe to proceed. Can you see? You need both. Now, what does AI add? A technical writer could carry out this assessment manually. Where AI becomes useful is when there are many tickets, specifications, transcripts, and test cases to examine. An AI agent or application can look for absent information. It can compare statements across several sources and turn a collection of unstructured notes into a consistent report. It can also reassess the source pack when a developer adds new evidence. But the report, the output, must show its workings. It should include the overall score and the category scores, any blocking conditions, and the evidence supporting each judgement, and missing or conflicting information, and the confidence of the assessment. It should also recommend specific actions that would increase the score and identify the person or role most likely to provide each answer. The evidence justifying the score matters more than the score itself. So how do you make the assessment fair? If people are going to trust the score, the process needs some safeguards. Firstly, score the source material, not the developer. The result describes the state of an information pack at a particular point in time. It's not a judgment of someone's ability or effort. Secondly, every score should point to evidence. If the AI awards points for documented error behavior, it should link to the test case, specification, or meeting transcript where that behavior is described. And missing information must be labelled accurately. If the sources don't mention a capability, that doesn't prove the product lacks it. It proves only that the evidence is missing. Thirdly, calibrate the system. Give the same completed source packs to several technical writers and to the AI. Compare the scores and discuss the differences. If a rule produces inconsistent interpretations, rewrite the rule. You should also record the model, prompt, and rubric version used for each assessment. And finally, allow a human override and record the reasons for it. A technical writer might decide that a low-risk wording change needs less evidence than a new authentication workflow. The process should allow for that professional judgment. Let's talk about how teams could use the score. The most immediate use is for triage. Writers can see which projects are ready to start and which need more discovery. The score can also improve feedback to developers. Instead of sending a general request for more detail, the writer can return a short list of missing facts and point to the relevant parts of the rubric. Teams that provide clear, verifiable source information should get some recognition as well. That might be cake, a certificate, or an email thanking the team. More usefully, you can share examples of good source packs and explain why they worked. Recognition for improvement is usually fairer than a league table based on raw scores. A readiness threshold could also become part of the definition of done. For example, a feature cannot move to documentation ready until it scores at least 80, has no blockers, and names an owner for every remaining question. At a management level, aggregated scores can reveal problems in the development process. You might track the percentage of source packs that meet the writing threshold, the most common blockers, the typical score when documentation is requested, and the time taken to resolve information gaps. Those measures tell you where information is arriving late and where ownership is unclear. But don't turn it into a developer league table. This is an important warning. Be careful about turning a documentation readiness score into a performance target for individual developers. AI doesn't remove the subjectivity from the assessment. It applies a rubric consistently, But people still choose the rubric, the evidence and the thresholds. Once a score affects performance reviews, people will optimise for the score. They may add material that satisfies the rubric without making the source pack more useful to the writer. A documentation readiness score is safer as a measure of the process rather than a measure of the person. Use it to ask why information arrives late, which questions keep recurring, and where responsibility is unclear. But don't use it to rank individual developers. The score should start a conversation. A documentation readiness score won't remove the need for technical writers to investigate, test, and question the product, but it can remove some avoidable work. It can get rid of some of the grit in the system. It can expose missing information while developers still have the details in mind. And it can replace a vague disagreement about whether something is ready or not with a clear list of evidence that's present, absent, or unresolved. Again, you're not looking for a perfect number. The goal is to make sure the writer has something reliable to work with. If you're exploring how AI could improve your technical documentation process, Cherryleaf can help. You'll find our contact details in the description. And if you found this useful, guess what? I'm going to ask you to subscribe to the channel so that you will get notifications of more videos on technical communication, documentation, and AI.